And now, Jobin, Rasmus, and I get to welcome to DevOps Decrypted Péter Bozsó, a channel solutions architect for GitLab. Péter, welcome.
Thank you, Ryan. Hi, everybody. Good to be here.
Hello, Péter.
Hey.
Péter, you focus quite a bit of your work on DevSecOps, but you're not necessarily here to talk about that. We're going to dive into MLOps in a second. But before we do, tell us just a little bit about your work in DevSecOps. What do you focus on in that area?
Usually, I would say it's not even my personal focus, let's say. So it's in the last couple of months or almost maybe years, DevSecOps is the overall strategy for GitLab, right? So I would say it's more correct to say that every solution architect at GitLab is very strictly focusing on DevSecOps right now. And we are different in kind of like which particular part of the security we are more narrowing into, or a certain technology or a certain partner technology, this kind of stuff. But I would say DevSecOps is really in the mind of everybody right now at GitLab. So that's like top of the strategy for us. And yeah, I am on that as well. I am approaching this whole topic more from the developer side, so like the dev part of DevSecOps, because my experience is more on the software engineering part of the whole DevOps, DevSecOps thing. So I usually looking at the security from that point of view.
So Péter, tell us more about MLOps and how exactly is it different from DevSecOps or DevOps in general? I mean, everything is ops these days. I think we even had a blog post spread it in the future, and we actually put that headline in there. Everything is ops. So how is it different? What exactly is MLOps?
Yeah, I think Jobin, you put it right. Yeah, everything is getting ops. We even have a thing at GitLab called MLOps. So yeah, everything is ops now. MLOps, I would say, I like to look at like, I think MLOps is essentially a superset of DevOps or DevSecOps. So in my point of view, MLOps have the exact same challenges and issues and difficulties as DevOps, and a little bit more even on top of that, just by the nature of machine learning, right? Because in traditional software development, so DevOps or DevSecOps, the logic, the main piece of deliverable that you do is basically the source code, right? That's what everybody is working on. That's what you review. That's what has the bugs, or that's what drives your business. And MLOps is that and a bit more, right? Because in MLOps you have it's model ops, right, or machine learning ops, or whatever how you say it. But let's stick to the machine learning ops. And in that case, what is a machine learning model is essentially, right, it's data, an algorithm, which is code, and some parameters. Essentially, this is what makes a model. So source code is there, definitely just like in DevOps, like in normal software development, but you put the data there as well and the parameters, and these three things together brings a lot of challenges on their own. So I would say it's something like that.
So I thought about this earlier in how do you contrast it to DevOps, and came up with the idea of looking at embedded hardware development, where you have some actual like physical pieces involved in the process. How do you speed that up? How do you DevOps?
Yeah, exactly.
Take a board and put it into the test stand. Just with MLOps, you're dealing with a model made up by data and so on, but it's still not kind of one of your traditional artifacts in that sense.
Yeah, absolutely. I think the similarity is certainly there. It's both of them are DevOps extended, so to say, with their own challenges.
So can you talk a little bit about some of the challenges that you experience just focusing on the data sets interfacing with the code itself?
Yeah, what we usually see inside GitLab at our customers is that data is usually very big data sets, right? So it's much bigger than just source code. And that's what it also makes it very difficult to version, right? Because source code, it's easy. It's just text files. You can compare, you can see. Even moving the data with Git is pretty quick, right? But doing that with data, it has its own challenges. So doing that with traditional DevOps tools is very, very difficult just by the sheer amount of the data that you have to move in between your local computer and the server. So because of that, we at GitLab looking at what the industry is doing and trying to incorporate some new features into GitLab to accommodate these needs, mainly the handling of the data together with the code, right? So not just like, okay, I have my source code in a Git repository in GitLab, and I have my data in whatever storage solution that you have. So we are trying to put all these in the same bucket with the parameters. So that's what makes up the model, and put the whole thing together on GitLab. So it can be one package, essentially one unit of data or machine learning or models, basically.
Okay, so if I'm curious, because I have to link everything these days to ChatGPT, if I had infinite money and was actually smart, and I said, I'm going to make a ChatGPT competitor, here's a GitLab, what do I do? Like, what's the first step? Is it something just like you read some blog entries and figure it out? Or are you going to put a nice big black button somewhere that just says, like, create MLOps thing?
It looks, certainly you need to read a bunch of blog posts. I would need to read a bunch of blog posts to start on ChatGPT. That's for sure. A couple of textbooks, but on the side of GitLab, so it looks like that currently almost all of the MLOps features that we have are either in private beta or will be in private beta soon. So in the currently available version of GitLab that is on GitLab.com or what you can install on your own servers, there are basically two main features that can be relevant for creating something like ChatGPT, so working in the machine learning space. One is actually not that relevant, but that's something that's there, that's usable for a long time now, is the Jupyter Notebook support that we have, and a lot of machine learning folks are using that. So Jupyter Notebook is essentially, you can think about such a thing like a document, which is very interactive. So you can have their text, some code, some algorithms, and you can present some data experiments in such a document. So that is first class in GitLab right now. So it works like, what I mean by having first class support for Jupyter Notebooks in GitLab is that when you are doing a code review as part of a merge request, you can actually render the Jupyter Notebook, because Jupyter Notebooks are just JSON files, essentially. So you can compare the JSON, but that's not really useful if you want to understand what happened. So what GitLab can do, it can render the page, and you can actually compare, okay, how the outlook roughly will look like. That's something that could be useful for machine learning, not strictly just for stuff like ChatGPT or something like that, like a really smart chatbot. What we are having and what is currently, I think, let me check my notes. Yeah, it's still in this dog fooding phase. So we are using internally, but it will be in private beta soon, which is the experiment tracking feature of GitLab, which is, I think, would be the most useful for developing something like that. So experiment tracking is essentially, you can think about it, it's very similar to a Git repository in terms of like storing the in progress stuff, so to say, so the code, not the finished artifacts. But in this case, it's storing machine learning experiments, which is, as I mentioned before, is basically data, the algorithm, and some parameters together. So that's something that could be really useful. If somebody is more familiar in this space about the tooling, it's essentially an MLflow backend integrated into GitLab. So MLflow is a tool which you can use. It's not by GitLab. I think it's an open source application actually. And MLflow is basically something that you can either host yourself or you can use the SaaS version. And it's a backend where you can store runs of your experiments, right? So you are running the experiment on your local computer with your machine learning algorithms and data, and it will store the different runs in the server. And that's something that right now or not right now, but soon you will be able to do in GitLab as well. So for example, if you are training an AI, something like ChatGPT, so the machine learning model for such an AI, that you can do on your local computer, but the end result of these experiments end up in GitLab, essentially. And everybody in the team can see, okay, changing the data set or changing this parameter will end in this result in the model, in the resulting model. So that's something that you could use. And another feature, which is still in just planning phase, essentially, so nothing have been developed for that, is model registry, which is essentially package registry just for machine learning models. So it's like a specialized version of our existing feature, which is package registry just for machine learning models.
That's a lot of information to unpack, right? And I just want to make it a little easier for our listeners. So what we are saying is there is a lot of features that's not currently there, but in the beta version that supports the ML workflows. And basically, you can start using that in the near future in GitLab. And if you want to create a competitor for ChatGPT, I mean, I probably wouldn't read a lot of blogs. I'll probably go and ask ChatGPT itself. But anyway, once we figure that out, we can then go use GitLab as a tool to do it. That's what we are saying.
Yeah, pretty much that's what I was saying.
So you did mention a couple of features already called out, the experimental learning workflow and how we can use the different modules within GitLab pipelines. So what is going to come out first? I mean, what's going to be the biggest feature that's coming out in the near future?
It's 100% the experiment tracking feature. So the one that you are using you are using your local computer to run the actual experiments, but the result of the experiment is ending up in the server. That's what is coming. And this is, as I mentioned, it's essentially a re-implementation of a backend of this tool called MLflow, but it's not like a 100% re-implementation. So MLflow does much more than just this. This is one feature of this open source tool, which we will incorporate. It will go into private beta, so interested customers can give it a try, see how it fits into the overall GitLab workflow. And based on their feedback, we will either implement more features from MLflow, or we will basically branch out and implement new stuff based on how can it better work together with the already existing GitLab features. But the beauty of this is that we are only re-implementing the server part, right? So MLflow works like that. You basically have a library in your own machine learning code, usually Python code, right? And that library is the same. You basically just telling the library, okay, upload this not to MLflow, but GitLab. So that's all you need to configure, and it works completely transparently. So that's why we choose this path, because we saw that many people are using this MLflow already. So it's much easier to switch if you don't need to rewrite all of your scripts, right? And everything that you've done so far, you just use the existing tool and just switch out the backend in the picture.
To clarify for the uninformed, such as myself, when you say an experiment is uploaded into GitLab, is that the artifact that is coming out of a machine learning run? What exactly is an experiment?
It's literally that. So an experiment is made up of the algorithm, which is literally source code, usually some Python code, the data, which is can be a big data set, a small data set, whatever, and a bunch of parameters. So basically you are saying, the model is basically the code. You are telling the code, okay, crunch this data with these parameters. That's an experiment. And that you can imagine it will spit out a model candidate. That's one experiment. And then you are a data scientist on your own laptop running these experiments with, essentially you change either the data set, either the code, either the parameters. Sometimes the only thing you change are the parameters, right? Everything is the same. Change the parameters, and you will see all of these experiments showing up in GitLab. You will see the result, and the result is essentially the model itself and some kind of data about the success of the model, which you define yourself, like, okay, this is the this is the metric. Metric is the right word here, the metric that I'm looking for. And you can actually see, okay, it improved based on my fiddling with the parameter or didn't. And then I can just say that, okay, I run this experiment 3 times, right? With different set of parameters. Okay, this was the best. Let's go with this one. I want to keep this one, the result of this one, because this actually improved the success criteria of my model. That's the whole workflow essentially with MLflow right now, and will be the workflow with GitLab as well when this feature will come out of the, so to say, dog fooding phase.
Okay, so speaking of experiments then, can you integrate that approach with the current way GitLab handles environments and sort of be able to promote an experiment into particular environments that use the data for something?
Not yet, but these are exactly the kind of discussion that we are having with the customers right now, right? So that's why we choose this approach, like, okay, just implement this very basic, or not basic, but core feature of MLflow. And these are exactly the use cases. But for example, there's a use case which you already got from our customers, like, let's imagine you have a merge request, right, for your machine learning model. And you would like to see in the merge request view if the changes that the person who created the merge request, the changes that he or she made to the model basically improve the metrics or not, right? So like a widget, like currently what you have with the code quality widget that you can see in the merge request, something like that we would like to integrate into the core GitLab workflow. So these are exactly the use cases that we are literally just thinking about, okay, how can we make it less like just a siloed feature and more like part of the whole GitLab workflow.
Neat.
How about testing? So what is happening on that side of things? How do you test these experiments from within GitLab as part of the pipeline? Is there something that you can do today?
So you mean like distributing the models?
So you mentioned about the success rate for experiments, right? How do you calculate that and make sure that you haven't introduced?
Yeah, that's on the side of the actual data scientist who is creating the experiment. So they based on the algorithm and based on what they want to achieve with the actual model, they define these metrics. So right. It's more or less part of that Python script that is crunching the data and outputting the model. It's outputting these metrics as well as part of this experiment run.
I see. And one of the major features that will help teams onboard is auto DevOps within GitLab, right? So are you planning to introduce any of these pipelines as part of auto DevOps?
Now, that's something that I have no information about, but actually also a very great idea, because I personally see a lot of my customers and partners just going with auto DevOps initially, right? So,
right.
Yeah, that would be actually really nice. Just like saying, okay, this, not even, you could do it the similar way that auto DevOps works right now, right? So you can just say, GitLab will recognize that this is a machine learning project and just configure auto DevOps in a way that, okay, this is like a pipeline for a machine learning project. That would be nice, yeah.
Péter, you can have that one on DevOps Decrypted. Just tell him Jobin sent you.
One thing that is of interesting to me when using GitLab as a tool was, small improvements that actually makes use of machine learning in the backend. Like, for example, when you create a pull request, it automatically suggests the approvers that can work on that pull request based on who is on vacation, who is not, who had been reviewing similar pull requests. It's a simple feature, but very powerful because you don't have to then consciously go looking for reviewers. And other features in GitLab like this, you're consciously adding using machine learning in the backend.
Yeah, there are some stuff that is brewing, but currently that's the one that's already in the product. That's what I would really, usually when customers ask me, okay, but can you give me an example how machine learning is used at GitLab? That's what I point them at. Basically, what we have is a product team at GitLab who is working just in this AI-related stuff that can be used as part of GitLab. And one of the most, at least for me, most exciting feature that more or less almost everybody in this team is working on. So basically the experiment tracking, which I mentioned, is a single engineer project. So at GitLab, we have a concept of single engineering teams. So like a team which has a single member, right? The point of that is that one person can iterate much faster on new stuff until this thing gets into a certain level of maturity. And at that time, a product team can take it over, right? So that's the experiment tracking. But we have another feature, which for me is very interesting, is I think we call it right now, AI-assisted coding or code writing or something like that. So basically, it's a competitor to GitHub's Copilot, right? Mm-hmm. Let's say it's GitLab's answer to that. So that's what I would say 99% of the engineering effort right now on the AI space inside GitLab is spent on that. And that's coming. And that will be also part of so we have this new web IDE. If some of you haven't missed or have missed the last update to GitLab. So that came into beta, which is like Visual Studio Code integrated into GitLab, right? Mm-hmm. So now if you edit code in the browser, it will be VS Code. And this AI-assisted editing will be part of that experience. I have no information about if it will be available on your local IDE as well, but honestly, I would be really surprised if it won't be. So let's see that. But these are the areas that are getting the most focus from us right now.
Yeah, definitely like the new IDE, and I have heard really good positive feedback about that. But basically what you're saying is GitLab as a tool, you can use it for, machine learning development, but at the same time, GitLab itself is implementing a lot of features that uses the power of machine learning behind the scenes and making life easier for developers.
Yeah, absolutely. And the most important part, I think, is that the MLOps features that we are putting into GitLab, we are using them as well, right? So GitLab, but this is always true about GitLab. So we use GitLab to develop GitLab. But the MLOps features, so for example, this experiment tracking is right now being used internally by our teams before it's going into private beta. So I usually that's what we do, that we try the stuff ourselves. If we like it, then we release it to our customers. If we don't, then just get over with it.
Good old dog fooding.
Yeah, absolutely. I'm reading my notes from a GitLab issue right now, so come on.
So what is coming up next? What is in this space that GitLab is not telling us yet?
Not telling.
You're allowed to tell us.
No, that's it. If there are something like that, even I don't know about it. Usually it's our own issue board is open, right? So apart from the security vulnerabilities of the GitLab project itself is open on gitlab.com. So it's as much open to everybody as it's open to me. Yeah, the biggest thing is really this AI-assisted code editing, I would say.
Péter Bozsó, Channel Solutions Architect for GitLab, thank you so much again for joining us on this episode of DevOps Decrypted.
Thank you very much, guys. Pleasure is all mine.
Listeners, what do you think of MLOps? Let us know in the comment section on YouTube or in your favorite podcast app.